Okay, we'll look at what you call mapping notation, and it's really translating or transforming a function, and really a way to transform when you know specific coordinates of a function. Okay, in this question they gave us a specific coordinate, right? They said that this coordinate 1, 4 was on our original y equals f at x. Oh, okay, so that's why they called it y equals f at x. So let's fix that part. Y here. On y equals f at x, whatever the function was, this coordinate existed there. The function is then transformed. So they use f because they don't really tell you what the function was. They're just saying it is a function. And they've put values in here. And we have to denote or figure out, in terms of our translating of a function, which variable represents which letter. So when transforming a function, we're used to seeing y is equal to a, and then whatever the function is, and they use f to represent that. Then we have k, and k is kind of like it's been either common factored out or it's about to be distributed into our x, minus d. And then finally we add a c at the very end. At least that's how you guys denote it. So in this case, we can easily pick out our letters. We know that 3 is A, K is -4, positive or -1, depending how you read this, and I'll talk about the differences between, is our D and then our C. So it's important to know how to extract D as part of this equation. The other three are pretty straightforward. The value you have is the value you'd get, and this is your mapping notation. So those are what you would plug in for each of these values if you know a coordinate like we know right now. The D can be confusing. Because there's a negative in front of the D, it's best to try to think like as if there's almost a negative between these two terms. Okay, so if you were to extract this, essentially what this was originally said, it was x minus some value. Oh, shoot. So like we're saying, there's x minus some value, and we have to figure out what value would turn this into a positive one. If we know our integer rules pretty well, we know that a -1 would kind of set this up so that'd be x plus 1. So depending on how your teacher reads it or whatever, your D can be either +1 where they want you to write it as positive, or it can be technically -1. And that's how this will change with your mapping notation. Sometimes the teacher will write it as x over k minus d, and if it's minus d, what they want is they want the operation in front of the actual constant term. They want it all together. If it's plus d, they want you to extract it properly. And to extract it properly means that you know that this is actually a -1. Okay, so that's really important there. Since we know how to extract it, we're going to leave it as plus d in this mapping notation. Okay, so now that we've done this, is pretty straightforward stuff in terms of where would this new coordinate be if it's been transformed through this equation. The first thing we're going to do is actually fill in our k, our d, our a, and our c. And we can actually write this as a whole new formula if we really want. We could say the new x is equal to x, or the old x, and we'll call this x old, y old. Okay, so there's a subscript there. Thank you for letting me know there's a virus. Divided by our k value. Our k value is -4 here, and then because it's plus d, what did we say this one was?
Minus.
Yes, so it's technically a -1 when we do it here. Okay, so we know we'd extract. So it'd be plus -1, and plus -1 is the same as just writing subtracted by 1. Does that idea make sense?
Yep.
Okay, so that's how we can find our new x value, and our new y value, y new, we can write it as, is equal to the old y. And I use a subscript just to, so we can tell the difference between our new y and our old y here. I actually didn't need to underline that. Times a which is 3, and plus our c value, and we're adding -2, so it's subtract 2. So it's really straightforward here. We'll work this out. We're just going to plug in what our old x value. Our old x value was 1, so x new is equal to 1 over -4 minus 1. And I'm just going to go right to left, even though that's not really how we tend to write it in math, which is equal to essentially -5 over 4, or -1 1/4. And our other one, our new sorry, not x, our new y is equal to 3 times our old y, which was 4, minus 2, which becomes 12 minus 2, which is the value of 10. So a lot of times we write it like this so that's already in our coordinate form. You could write it straight out like a formula the way I have here. It doesn't matter as long as you know how to turn it back into a coordinate, which would be 5 over 4 and 10 as our x new, so our new coordinate once it's been transformed, and our y new.